Hey there, we are the Study Buddies. In today's mathematics addition video, we'll be learning about logarithms. So, what is the meaning of logarithms? Logarithms are basically the inverse of exponential. So, if you want to remember what exponential is anything which has an index on it, like for example 1 square. So, the inverse of this is called logarithm. So, how are we going to write logarithms? So, let me explain using a simple shortcut method which I would recommend you all to remember. It's very easy to remember this method. So let's say I'm having y equals to a to the power of x. So how am I going to convert this or inverse this into a logarithm format? So it's very simple. So once you see an equation like this, just pull an arrow from the the one which has an index, and pull the arrow from the one without the index, like this. One directly down 90 degrees and another one around 120 degrees from here, something like that. Okay, so once you have pulled it like that, just write it down again. So a, write it a bit small, and y, write it in a big way, and just something like that, and equals to x. So y equals to a to the power of x is the same as log a y to the power equals to x. So this is actually the base. Okay, so let's take an example. Let's say I'm taking 4 equals to 2 square. So how am I going to convert this to logarithm method? The same thing. So 2 4 log. So therefore log to 4 is equals to 2. So now we'll be looking at a few examples so that you can understand this much clearer. So let's look at our first example. 10 to the power of negative 1 is equals to 0.1. So how am I going to convert this to logarithm? So just a free advice or free tip, bring the power to the right hand side of the equation. So it's something like this before you convert to logarithm. Then after that, just pull the arrows as I mentioned. So 10, 0.1, log 10 to the power of 0.1 is equals to negative 1. Okay, so that's all. It's just simple as that. Just pull the arrows and you can convert an index equation directly to a logarithm equation. Okay, so now I'm going to explain another important thing which links index to logarithm. So if you are aware, if you watch my video on indices or index, or if you are aware of the law of index, anything to the power of 0 is automatically equals to 1. So same goes to logarithm. So I'm going to convert this to logarithm. So 1 equals to a to the power of 0. So I said arrow again. So log a1 is equal to 0, which means that anything which has 1 after its base is going to bring a result 0. Let's say if I put a equals to 2, so log 2 1 is also going to be 0. Log 1001 is also going to be 0. So anything which has 1 after its base is automatically a 0. So now let's look at another example, another important thing which we have to take note, which is this. So anything to the power of 1 is the same thing. So a to the power of 1 is equal to a. So how am I going to convert it to logarithms? Again, I'm just going to pull arrows. So log a is equal to 1. So whenever you see a logarithm, you see the base and the number after the base is equal. Let's say log 2 2. So the answer is automatically 1. Why? Because they are the same value. So let's say log 5 5 is also 1. Log 1000 is also 1. Okay, so now we have another example, and the question says find x. The x, just joking, jokes apart. Okay, so now if you want to find x, what we have to do is that we have to convert this whole logarithm into indices format. So just a recap, I'll just write down a simple reminder over here. So how we converted what we call that, index to logarithm. So we wrote a y log ay is equals to x. So now how do we convert logarithm to index? just refer to this whole template. You refer to this template, and you, based on this, you can just directly write your index. That's the easiest method which I would suggest you all to use. Rather than complicating yourself, just make this as an easy practice. So x a, so x becomes the main thing over here. 1 to 5 comes here, so sorry, 1 to 5 comes here, so 1 to 5 and cube. So I'll just turn it back. So x cube equals to 125. So if I bring this cube to this side, it becomes cube root 125, and thus my answer would be 5. Therefore x equals to 5. So you can try in your calculator and see, and it really works. So now we are going to look at two types of logarithms which we generally find. So there are only two types of logarithms: common logarithm and natural logarithm. So what is common logarithm? Common logarithms are logarithms which have the base 10. So the number here is always 10. So let's say log 10 is going to be 1, log 10 100 is going to be 2, and so on. So the base here, if the base here is 10, it is immediately a common logarithm. So common logarithm, our calculator usually uses common logarithms. So as a proof, log 10, I'm going to get 1. Okay. So next we're going to look at natural logarithms. So what are natural logarithms? Natural logarithms are logarithms which have the base e. So you might wonder, what is e? So e is actually an irrational number, and I think if you watch my video on real number systems, you can understand what is irrational numbers. So alpha, this ln symbol here, e, you can see the value of e, which is 2.718, and the number goes on. So any logarithms which has e as its base, so log e 10 equals to some number. So anything which has e as its base is called a natural logarithm. However, natural logarithms are not usually expressed in this way. Rather, they are expressed in a much simpler format called ln, or we call it as ln. So ln symbol can be found here on the calculator. Okay. So natural logarithms are expressed using ln. Common logarithms are expressed as log 10. So now we are going to look at the properties of logarithms. So there are a lot of properties for logarithms. So let's move on to our first one. So whenever you see log a, any log with a power, with the number next to the base with a power, you can just bring the power downwards over here and write it in this format. So for, let's say I am having log 3, based on this, log 3 9 to the power of 2. So immediately I can write this as 2 log 3 9. So actually the answers for both of these, if you put in your calculators, it's going to be the same, which is so the answer is going to be the same. I'll teach you how to do this later in a moment. Okay. So therefore, any number, any log with a power, you can just bring the power to the front and write it in this format to make it easier for you all. So the second property is any log which has a multiplication, or any number which can be separated into 2 with its factors, like for in this case mn, can be split into additions. So any number in a multiplication format can be split into 2 individuals and added to each other. So I'll prove this to you. So first I'll do this part. So just substituting the values, it becomes log 2 4 times 2, which becomes log 2 8. So log 2 8, you can simplify this 8 into 2 to the power of 3, so it becomes log 2 2 to the power of 3. So log 2 to the power of 3, as I mentioned just now, if there's any power you can just bring it to the front, which makes it log 3 log 2 to the power of 2. So log 2 2, since the numbers are same, it's actually 1. So 3 times 1, therefore the answer for this whole thing is going to be 3. So now let's try using this part. So log a is 2, m4 plus log 2, 2. So 4 is actually 2 to the power of 2. So log 2, 2 square plus log 2, 2. Since the numbers are same, you can just write it as 1. So since there's a power here, just bring it down. 2 log 2, 2 plus 1. So log 2, 2, same number. So 2 times 1 plus 1, it becomes 2 plus 1, and therefore the answer is 3, hence proving that this side and this side is the same. So therefore whenever you see any number, like let's say you are seeing 12, so you can just split its factors, like 1 times 12, 2, 6, 3, 4, and then you can substitute as individual numbers. So the next property is a division means minus. So m divided by n, you can write it as log am minus log an. So just now, if you notice properly, just now it was multiplication and we did an addition. So now it's a division. So we are doing subtraction. So let me prove this to you. I'll start off with this side. Log 2 8 over 4, which brings us to log 2 8 divided 4 2. So 2 is the same number, so the answer is 1. So on the other side, log 2 m is 8 minus log 2 4. So 8 is 2 to the power of 3 and 4 is 2 to the power of 2. So we bring the powers to the front. So 3 log 2 2 minus 2 log 2 2. So since we notice that it's the same number, we can just change it to 1 minus, where 3 minus 2 brings us to our final answer 1, which matches. So therefore whenever you see a division, you can just denote it as this format. So our next property is log a power of 1 over n, log a 1 over n is equals to negative log a n. So why is this happening is because I'll just take 1 over n. So 1 over n can also be denoted as n to the power of negative 1. So if I'm replacing this here, it becomes log a n to the power of negative 1. And as I mentioned before, you can bring the power to the front, which means negative log a to the power of n, which is exactly same to what I've written up there. So next property we are going to look at is log a to the is when we want to change the base of a logarithm. So how are we going to change the base of this logarithm is that we are going to split it. This will go to the numerator and the base will go to the denominator, and we are going to replace it with a new base. So let me show you an example. So let's say if I were to change log 4 8, I'm going to change the base to 2. So I'm just going to take base 2 and insert it, and the number here is going to go to the numerator and the base is going to go to the denominator. And now if you observe, I've changed the base. So I'll just solve this question. So log 2 to the power of 3 over log 2 to the power of 2, which brings us to 3 log 2 over 2 log 2. So 3 times 1 over 2 times 1. So the answer is 3 over 2. Okay. So for this last property, we are going to look over here. For this property which we are going to look over here, if the base which we are going to change, let's say if you are going to change the base a to a base which is similar to the number here, it would become 1 over log ma. So why? I'll just show it to you. So let's say log am, I'm going to change its base to m, so it becomes log m over log ma. So if you observe I can change it to 1 over log ma, which is similar to the property which I've mentioned before. So therefore whenever you realize that the base is exactly the same as the number here, just write a 1 here. Or if you feel like you want to play safe, then just follow the whole method, which I prefer. So now let's move on to the properties of natural logarithms. So I'll be only explaining one out of the other properties, because the other properties are exactly the same as what we have looked at logarithms just now. So the first property, ln e to the power of x is equal to x. So how is this possible? So ln e to the power of x, as I mentioned before, bring the power to the front, which means x ln e. So ln is actually log e. So log e, if you notice, this is actually 1, so therefore x times 1, and you get 1, proving this whole property. So I'll just list down the other properties for your comfort. So these are the 9 properties, other 9 properties which have the exactly similar explanation as logarithms. So just take note of these properties for us to solve the questions later. So before we finish our video, we'll be looking at several examples. So look at this example. So log a bracket b over square root x plus log a square root of bx. So what we have to do first when we look at this question is we have to split all of this into individual logs. So log a b minus log a square root x plus log a square root b plus log a square root x. So now once you look at this equation, you can see that log a square root x can minus off log a square root x. So therefore now the only thing balanced is log ab plus log ab square root b. So I'll just change this to index form. I'll change the b to index form, which is log a b to the power of 1 over 2. So just to recap, b to the power of 1 over 2 is similar to square root b. So log ab plus, I'll bring the 1 over 2 to the front, 1 over 2 log a b, which brings us to our final answer, 1 plus 1 over 2, 3 over 2 log a b. So this is the answer for this question. So this is how you have to solve the question. So first you split everything, then after that you see plus accordingly. So now if you observe properly, why I could plus 1 over 2 log ab to log ab is because it has the same variable. So that's the whole reason. So in our second example, ln 3x square minus ln bracket 9x to the power of 1 over 2. So we'll do the same thing again, which is we are going to split everything into individual lns. So this would be ln 3 plus ln x square minus ln square root 9 plus ln square root x. Okay, so once we have looked at this question, once we have separated it into individual lns, we solve each ln individually. So ln 3 remains, so ln x square can become 2 ln x, bringing the power to the front, and this becomes minus ln 9 to the power of 1 over 2 plus ln x to the power of 1 over 2. So bringing the 1 over 2 to the front, or in this case we can actually solve the 9 to the power of 1 over 2, which brings us to ln 3 plus 2 ln x minus ln 3. So because square root of 9 is ln 3, square root of 9 is 3 plus 1 over 2 ln x. So ln 3 minus ln 3, we can just cancel it off, bringing us to 2 ln x plus 1 over 2 ln x. So since the coefficients are same, so we can just directly do 2 plus 1 over 2. So 2 plus 1 over 2 brings us to 5 over 2 ln x. So this would be the answer for this question. So that's all, just have to split it, then you have to solve. So a very important tip to score and to solve logarithm and ln based question is to really remember the properties so that you can face it easily. So the question 3 gives us an important information. Log A2 is 0.431 whereas log A3 is 0.683. So now I have to find log A72. So what I have to do first is I have to find the factors of 72. So I think I would not like to waste time doing this, but I request you to do it by yourself. So from what I did, I got log A 9 times 8. Sorry, 9 times 8. So once I get 9 times 8, I would like to split this into two separate logs. So log A9 plus log A8. So with this information I can definitely answer this question, but the problem is the question has only provided numbers 2 and 3. So what I should do now is that I should change these numbers into 2 and 3 respectively. So 9 I can change it to 3 by doing this. So log A3 square, which brings us to 9, plus 8 I can change it to 2 by making it like this, log A2 cube. So as I mentioned before, just bring the powers to the front. So 2 log A3 plus 3 log A2. So since we have numbers for log A3 which is 0.683 and log A2 0.431, we can just substitute them and calculate this, and you will get an answer of 2.659. So this is how you answer this kind of question. So whenever you see only this much of information is given, the best thing to do is to find the factors of this. So it goes on and until you get a number which convinces what information the question has given. So let's say the question is asking express x in terms of y. So now I have to make it x equals to something something which has y. So how do I solve this question is that I would try to maintain x on the left hand side. So ln x equals to ln y plus ln 5. Okay, so ln y plus ln 5, it's actually ln 5 times y, which is ln 5y. So ln x equals to ln 5y. So now I'll just cut off the lns, and therefore the answer is x equals to 5y. Simple as that. So whenever an express question comes, just try to do this. However, a final piece of advice before I finish my video, two pieces of advice. One, please remember the properties of logarithms and lns in order to master this chapter. And my second piece of advice, do a lots and lots of practices. I've also provided you with practices under the description, so please do it as well. And yes, so that's all for this video. I hope you like this video. If you like this video, do press the like button and do comment if you have any doubts. Please share this video to your friends who need this, and don't forget to subscribe and click the bell icon. That's all for today. Take care. Goodbye.